Good afternoon, ladies and gentlemen, or good morning. Hey, so last time we talked about how to name um, compounds. So basically, I gave you a formula and we worked to find out how to name it. So I would give you something like MgCl2, and you would have to name it magnesium chloride, or this K2SO4, and you'd have to name it potassium sulfate. So today what we're going to do is we're going to go in the opposite direction. We're going to work on taking the name and creating a formula. So before we do, let's just quickly review what it means to have a charge or be an ion. So we talked last time about what an ion is. It's a charged particle. And these charged particles, which are on the periodic table, when these particles or these elements are ions, they have very specific charges to them. For example, as a quick reminder, everything in this column has, oh, that was a horrible circle. Let's try that again. Everything in this column, ladies and gentlemen, is a +1 charge. Everything over here is a +2. Everything in here is a +3. All of these, fluorine, chlorine, bromines, are -1. Oxygen, sulfur, selenium, -2s. Nitrogen, phosphorus, etc. And carbon, silicon, -4s. Nitrogens, -3s. So with that said, we're just going to do a quick review. So what is the charge on a sodium? Okay, what would be the charge on a sodium ion? All right, so the charge on a sodium ion would be +1. Good job. What's the charge on a scandium ion? So a scandium ion. That's right, it would be a +3. Good. What's the charge on oxygen ion, also known as oxide, which you learned last class? Good, it's a -2 charge. And the bromine, an ion that's a bromine or bromide? That's right, it'd be a -1. So let's just show how we'd write that. We would write that as Na with a 1+ charge, or you could just write Na+. Scandium would be written as scandium, and then up here in the upper right-hand corner, which is where we put charges, there would be a 3+ charge. The oxygen, you have an oxygen with a 2- charge, and the bromine, ladies and gentlemen, has a -1 charge, but we just put a minus sign. We don't have to put the 1 in there. So that is how we find the charges on the ions. Now these in here, like I said last time, we're not going to worry about the charges on these right now. We're going to worry about those next class. So let's continue. So now, what is the charge, ladies and gentlemen? Okay. What is the charge now on a carbonate? Okay, on carbonate. Well, carbonate is not on the periodic table. It ends in these 8s, right? Or hydroxide, which is no element. All right. And so we can find those on the polyatomic ion sheet. So we're going to come over here, and carbonate, you might not know whether it's positive or negative. So I'm giving you the name, and we can look, and it's not there. So let's scroll on down and take a look. And voila, carbonate is sitting right here. What is carbonate? Carbonate, ladies and gentlemen, is a carbon with 3 oxygens and an overall charge of 2-. Another way to write that would be, you can't write it this way, but it would be CO3, and then this entire CO3 has a 2- charge. The 2- isn't just on the oxygen or the carbon, it's on the entire thing. All right, so carbonate is CO3 with a 2- charge. 1 carbon, 3 oxygens, 2-. The next one, phosphate. Where do we find that? We'd have to come over here, and sure enough, phosphate sitting right in here. Phosphate is a PO4 with a 3- charge. Okay, PO4 with a 3- charge. Hydroxide, if we come to our chart, we'll find it. High, oh, there it is. Hello. Hi. Hydroxide is going to be an OH, and there's a minus charge on the entire OH, a 1- charge. Okay, great. So let's move on. Now, again, what we're going to work on today is why do formulas have the forms they have, or why do compounds have the formulas that they have? Well, we're going to take a quick look at water. Why is water H2O? We all know that water is H2O. Why isn't it H3O or HO2? Well, let me show you why. It's because there are two hydrogens. If we look at the hydrogen right here, hydrogen has a +1 charge, and oxygen has a -2 charge. And when we put those two together, ladies and gentlemen, you're going to need one hydrogen, which has a plus charge, another hydrogen that has a plus charge, and the oxygen that has a 2- charge, and that makes a 2+ balancing out a 2- charge. And that's why we have H2O. If we made H3O, or 3 hydrogens, this wouldn't be balanced. The charges aren't balanced. So you end up with 2 hydrogens for every 1 oxygen based on their charges. But we're going to do some more of that right now. So let's take a look at what we have. Whoops. All right, so we're going to work on this balance beam. This is going to help us balance some charges. So, oh my gosh. So on this balance beam, ladies and gentlemen, you can see that there is a circle that has a 3+ charge, and you can see that there's a square with a 2- charge. We need to have opposite charges on each so that the charges cancel each other out. This whole thing has to equal 0. So a +3 and a -2 doesn't add up to 0. It adds up to a +1. So we can only add circles worth +3 and squares worth -2. So right now, they're not balanced because it's a +3 to a -2. So that doesn't work. So let's add another square. Well, if we add a square, that square has to be worth a 2- charge. But now we have a -4 on this side of the balance beam and a +3 over here. So then we're going to add another 3+ over here. And that 3+ and the other 3+ is going to be 6+. But then we're not balanced, so let's add another square. And we're going to end up, hey, look what we did. Now we have a 6+, which cancels perfectly out a 6-. So we have 2 circles, okay, which are going to balance out with 3 squares. So you can see that we have a balance of charges. So 2 circles are going to balance with the 3 squares. And now what we want to do, let's just take a look at that and see what we have. So you have 2 circles balancing, 2 circles balancing the 3 squares, and that's going to give you a 6+ balancing out a -6+, right? So if we were going to write this formula, we would say, well, we have 2 circles, right? We have 2 circles, and we have 3 squares. And this is how we could write the formula. We'd say, well, it's a 2 circle, 3 square. And that's going to lead us to our next example. We're going to do a real example now. So we're going to solve for the formula for scandium oxide, ladies and gentlemen. So we're going to solve for scandium oxide. So in solving for scandium oxide, we're going to need to have, So in solving for scandium oxide, we're going to need to have some information. First, we have a formula. We have scandium and we have oxygen. So we're going to have scandium and we're going to have oxygen. Okay? So scandium oxide is going to be Sc, and then there's going to be a number down here. And then we're going to have an oxygen, and there's going to be another number right there. Now, I'm going to erase that just so the numbers aren't there, but just to understand that the little numbers, the subscripts, tell us how many of each we need. But before we can do this, we want to know what we're dealing with. What is the charge on a scandium? Scandium has a 3+ charge, or a +3 charge. And the charge on the oxygen, or the oxide, is a -2 charge, which means that every scandium has a 3+ charge and every oxygen has a 2- charge. So what we need to do, we want to make a balance beam, ladies and gentlemen. So let's make our balance beam, and we're going to put scandium on one side, okay? And we're going to put oxygen on the other. So here's our balance beam. So Are these balanced, ladies and gentlemen? Does the +3 balance out the -2? Nope. We're going to need another scandium, and we'll need 2 more oxides. And do these charges balance out? Yes. Over here, we have a +6. Over here, we have a -6. And those charges will cancel out to 0. Okay? And that's what that is. These charges are going to cancel out to 0. And so when we look at this, we could say, if we draw this thing out real big, we'd say, well, we have our 3 oxides. We have our 2 scandiums. So what would be our formula? How many scandiums did we use? How many oxygens did we use? And there it is. We used 2 scandiums, right? And 3 oxygens. And that would be our formula for scandium oxide. So we're going to try to write some formulas right now. If you get stuck or confused, see me during class, or I suggest you rewatch the video because this is very straightforward. When figuring out, you just have to find the pattern, okay? So let's try and write some formulas. First off, we have sodium and chloride. Sodium is right here, Na, and chloride is way over there. So we have Na and a Cl. And we want to know, what are the numbers that we're going to put there? What are the subscripts going to be? Well, what's the charge on a sodium? That's right, sodium has a +1 charge. What's the charge on the chloride? Chloride has a -1 charge. And do those charges balance out? Yes, which means the formula is just going to be NaCl. There are no little subscripts that go in there because the +1 balances out the -1. I'm going to change the colors. I think that might be easier for us. I'm going to work with red and blue. Now we have calcium fluoride. So we have calcium and we have, I'll just keep it all red actually. So we have calcium and we have fluorine or fluoride. And we want to know, what are the little numbers that go down there? All right. Calcium, if we take a look, calcium has what charge? That's what we want to find. Okay. Calcium has what charge? Well, calcium has a 2+ charge. Fluoride has a -1 charge. Do those charges cancel out? No. What are we going to need? You're going to need another 1- charge, right? Because fluorides only come in packages of 1-. All right, so another way I could write that would be, and I'll write it up above because we can't write it in there. You'd say each fluorine has a - charge. Each calcium has a 2+ charge, right? That's why I'm writing it over the fluorine and over the calcium. Calcium has a -1 charge, so you need 2 -1s to balance the -2. So the formula would be CaF2. 1 calcium, 2 fluorides, so that the +2 balances out the 2 minus the minuses, right? You have a -1, 2 of them. So this is a -2 side. That's a +2 side. Let's take a look at barium phosphide. Barium phosphide, ladies and gentlemen. Let's find barium. Barium's right over there. Barium has a 2+ charge, so I'm going to write it a little differently. I don't want to write it like that because I don't have you in the classroom. Barium has a 2+ charge, and phosphide, which is right over here, has a what charge? A 3- charge, or a -3 charge, right? Do those balance out? No. If I had a balance beam right here, I would say, well, you've got a 3- over here and a 2+ over here, right? How many of each would you need? Well, in doing math, you can probably see the common denominator is going to be 6. So you're going to need how many bariums to balance out how many phosphides? Well, 2, 2, 2 is going to be a 6+. That's going to be a 6-. They cancel out. What would the formula be? The formula would be Ba, and you needed 3 of those. And P, you only needed 2 of the phosphorus. All right. Let's take a look at the next one here. I'm going to change the color to blue so we don't get confused. We're working with potassium and we're working with oxygen. What is the charge on potassium? That's right, it's a +1. What's the charge on the oxygen? That's right, it's a -2. So do these balance out? If I had a balance beam here, does the potassium balance the oxygen? Nope. So we're going to need another potassium. Here we have a plus and a plus. That's worth 2 plus over there. This is a 2 minus. Those charges balance out. 2 potassiums cancel out 1 oxygen. So the formula would be K, and there's 2 Ks, and an oxygen, O. So the formula would be K2O. And that's how we would work out writing formulas from the name. Now we're going to write formulas for non-binary compounds. Non-binary is when you have more than 3 elements in there. So, but it's exactly the same. There's just a couple of little caveats that you have to do. So sodium and nitrate. Well, here's sodium right here. There's sodium. Sodium is an Na with a +1 charge, right? So I'm going to rewrite that for you. I just add a little more space, okay, so that I could have some more space. There's sodium. I'm going to draw a balance beam here. So that's a sodium. That's an Na with a +1 charge. Now we have to find nitrate, but you should be going, nitrate, that is not an element, Mr. P. That's going to be over here. So then what we have to do is find nitrate. Here's nitrate, a polyatomic ion. And that's NO3. And the key here is to understand that there's 3 oxygens and a minus charge. So if these are on a balance beam, and each one of these is a -1, and each sodium is a +1, do they balance out? Yes, they do balance out. So the formula would say I need 1 sodium and 1 nitrate. So I would just need NaNO3, and that would balance those out. So let's take a look at the next one. Here we have calcium hydroxide. All right. So here's calcium. Let's draw a balance beam. And we have a calcium. And where's calcium? Calcium's right over here. What's the charge on a calcium ion? That's right, it's a 2 plus. And then we have hydroxide. What's hydroxide? I don't know. Let's go find it. So then we come down here and we look, and we say, oh, look, there's hydroxide right there. So here's our hydroxide. Hydroxide has a -1 charge. All right, kids, we're at 20 minutes right now. Hydroxide has a -1 charge. Do those charges balance out? A +2 with a -1, do they cancel perfectly? No, they do not. All right, so the +2, it's too much. So we need another OH minus. So there we have another OH minus. Okay, we have another OH minus, which means 2 minuses over here, 2 pluses over there, they balance. Now to write this out, this takes a little bit of practice. So you're going to write the calcium, you'll write the metal, and then you write the polyatomic ion, or these guys over here. You need 2 of them, but you cannot put the 2 right there because that means you have 2 hydrogens. You don't have 2 hydrogens. You have 2 of these hydroxides. So we put parentheses, which you've seen before. You just didn't know what they're for. You put the parentheses to say we need 2 of these -1 charged compounds with this 2 plus compound. Okay, so let me get the screen set up for you. All right, so now we're going to work in purple. So now let's try to write the formula for barium phosphate. Right away, you're probably saying phosphate, that's a polyatomic ion. Barium is a metal. So let's find barium. Where's barium? Oh, here it is right here. You'll probably notice that right now, everything is in either column 1, 2, or 3. All right, so we have barium. So if we drew our little balance beam, right, we have barium, which has a charge of, that's right, 2 plus. And now we have to go find phosphate. So we're going to come over here to our table and find phosphate. And let me do that one again because I don't want to cover up that charge. So there's phosphate right here, right? And once we have phosphate, then we go, okay, now we know phosphate is PO4 with a 3 minus charge. So now, how many of each are we going to need? Well, we're going to go back. We have a 3 minus and a 2 plus. I'm sure a lot of you are sitting there going, Mr. P, the common denominator is 6. Yes, but not everybody's going to be doing that. So what you're going to do is, I'll erase this here. you're going to have to add, ladies and gentlemen, bariums and phosphates. So at this point, if I add another barium, the total charge over here is +4, and that's a -3. So if I add another phosphate, the charge over here is now -6. The charge over here is +4. That's not good. But if I add another barium, 2, 4, 6, a +6 balances a -6. And so this is what we need. We need 3 bariums and 2 phosphates. So it'll be written as barium, and I need 3 bariums. And then I need phosphate, PO4, and I need 2 phosphates, 1, 2. Do I put the 2 here? No, because that would mean I have 1 phosphorus and 42 oxygens. That's not going to happen. So what I have to do, excuse me, is I have to put parentheses and put my 2 right there. There's my barium phosphate. All right, so ladies and gentlemen, one more example before we leave. Let's put this one, let's do this one in black. All right, so potassium sulfate. Okay, we've got potassium. And let's make a little balance beam again. Kids really like the balance beam. All right, you're not in my class, but they like it. So you have a K+. Now we have to go look for sulfate. So let's look over here. And sure enough, boy, this thing's set up perfectly for us. There's sulfate. It's an SO4 and a 2- charge, which means that each one of these have a 2-. Each potassium has a +1. So are these balanced? No, they are not balanced. This is a -2 charge. This is a +1 charge. So I'm going to need another potassium with a +1. Oh, I didn't show you where potassium was. There's potassium. So potassium's a +1 charge, right? So I have 2 potassiums and 1 sulfate. This is exactly the same as what we did. The only real difference is using parentheses when you have more than one conversion factor. When you have more than one polyatomic ion, or one of these PO4s. Notice, do I put parentheses right here? No, I do not. Why? Because I only need 1 sulfate, and I already have 1 sulfate. So, ladies and gentlemen, that will be the end of our lecture today. So we're going to be moving into your homework. Your homework's exactly the same as last time, only you're going to have to take this here and say, okay, what is my answer? Well, you're going to say, well, strontium bromide, strontium. There it is. There's strontium. And there's bromide. And do they balance? This one is a +2 charge. This one's a -1. So we're going to need 2 bromides to balance out that -1 charge. And you're going to finish this whole sheet all the way down. And I gave you an example of magnesium chloride and an example of calcium nitrate for you to follow. All right, so with that said, kids, have yourselves a great day. If you have any questions, I'm right here for you.